RAM connection is a software which is used for the design of base plate, beam column connection. Almost all type of connections can be designed in the RAM connection. In this lecture, I will discuss about how to design a base plate in RAM connection software. So here is example. Design a hinged base plate for a W360-305. W360 means that is in SI system. In FPS system, in inch foot system, that is a W12 into 305. 305 is a unit weight of unit length. Column having a total factor load of 5000 kilonewton. Use A36 steel and concrete of 3000 psi compressive strength. So now I will go in this. That's the previous model. Open, close. I will start from scratch file, from new file. Here there is a joint type, that is a column base. So all different types of connections you can study here, the connection types. Here I am in this CB column base. If there is a brace on the right side or left side, you can select, but that's a simple hinge base plate, so no brace in the left or right. The type of the section, that's our section is prismatic, means throughout from bottom to top is same. That's the opposite connection, tapered connections. So our connection is our section is prismatic, and section is W12 into 305. Okay, you can select according to your requirement, W section, tube section. So all other different types of section is also present, HP section. Okay, and the material is A36 steel. Okay, there is also other options, other materials are present, you can select according to your requirements. Okay, so here is a column. Now I will define the load patterns. Here only the live load, self weight is not considered. It basically in 5000 self weight, live load, all loads are considered. It's a total factored load. So I will just select add. Here is a dead load type. I will click it to live load, and description, that is a live load, yeah, or total factored load. Type is live load here. Okay, and you can also when you go edit in the loads, you can define the loads. First of all, make sure the unit system, what unit system are you using, that's our SI. Okay, in SI lengths are in meter, and axial loads and shears are in kilonewton. Okay, now I will go edit. Here is the loads option. Here I will assign a load. Here is the axial 1 axis, that is a 2 axis, and that is a 3 axis. Just like in XY axis, that is X, Y, and third one is Z. In the axial upward direction is positive, and the for application of 5000 load downward, I will write minus 5000. Okay, and for the moment M22 major moment about the major axis, about the minor axis, you can see and you can understand the moment notations. Okay, the load have been assigned, and load assigned concrete material is 3000 psi. Here is the materials for the RC. Here I can check what is the strength of this concrete. Here is a edit option. Here is a type reinforced concrete, and ultimate concrete strength is 3000 psi. Okay, I will select OK. C340, and here is a connection types. multiple connections you can study, bolts, welds, anchors, all types. For example, what type of weld, that is a weld strength 70 ksi, 60 ksi, you can select according to your requirement. Not is given in this example, so we'll take it as default. And here is the anchor sizes, 1 by 4 inch, half inch, 1 inch, and different sizes of like anchors are present. So now I will go in the design. In the design I have to select the code, that which code I want to follow. So here is a different codes. You can select according to your requirements. So you can also follow ASD, LRFD. So I am following the LRFD method, and here's a total factor load, live load only 5000. Here I will assign the now connection type. What type of connection type is? Here is a basic connection type, so I will go in the base plate connections. Here is a smart pin base plate, matlab for the hinge connection, that's the option. For fixed connection, there are also other options you can study. Here I am clicking a smart pin base plate. When I click, shear and moment connection pin base plate was assigned to joint 1, close. It will take some time and then show the joint. Okay, here you can see. Now after we have assigned all the things, steel material, concrete material, section, now we will run the design and optimize the section. Here is edit. When we will go, our software automatically design the data, and here you can study all the things. Analysis load, that is a 5000. Analysis type, major axis, both axes you can select, but our load is axial, so it doesn't matter. Uniform pressure and steel design code 2010 LRFD for the concrete, ACI 31808. And here is the optimization area. We have put the loads, the software automatically optimize. The maximum thickness we have provided, that is 76.2, minimum thickness 6.35, and the increment is here. Similarly for base plate size, maximum distance, so these are the things software automatically optimize. Okay, then the minimum effective embedment length for the for our bolts, that is a 12 inch 304.8 millimeter. Our section type is prismatic. Here is our section material. For the base plate, if we want to for example, here I will click the 3D model. If we want to provide the stiffeners, so we can provide the stiffener plates. It's up to your requirement, but in our problem that's not present. And for example, if you want to not present this column as a center, maybe it's a eccentric footing, so you can select up to your requirement, lower left. So similarly, so in this problem that will be centered, so no option is present. So here is the thickness material, here is a weld size, that is a 5 means 5 by 16 inch. So that's a spot, means pedestal, that is the dimensions. You can also in the DXF file more clearly see that is a 2.44 meter. Here is a 2.44 meter. LX, LY you can change up to your requirements, or you can optimize. If your design value is less than 1, then your design is okay. For example, here I am changing something that's 1. Here is you can see the values change, means error. So I will just optimize so that it will not go in the failure. That is 1500. Okay, and the 1500. Okay, I am changing, reduces the size of the pad, but our design is still okay. So here is a top view, lateral view, front view, anchor detailing section. So the bolt detailing is also given. Here is our material type, that will be C40. Okay. We can also click optimize. Software automatically optimize after changing. When we click the optimize, the software automatically optimize the value. Here is the anchor position. So for example, if we want the rows per, for example 2, you can increase the number of bolts depending upon your requirement. So for this example, this will be okay. I am not playing with that, you can study. So here is the options. So software after automatically optimized. Now these are the base plate sizes, and these are the footing pad size. For the detailed results, you can click results. Software will tell all the detail analysis results, what are the sizes of base plate, concrete base, column, all types of things. And there is a one beautiful thing, that is the formulas, that is the FEM finite element method models. You can also see that this is the same area, means all the area is in compression, and here is the results. So the beautiful thing is that, for example, you want to see the formula, how the software is calculated the following things. Here you can select the view formula. When you will click, software also show you the formulas, how the software calculated. So here you can see these are the checks, ratios, that should be less than 1. So that's how we can design the base plate in RAM connections. Thank you. Have a nice day.